what is static shock and how do you prevent it from ruining your electronics?
Hi, I'm Paul, this is Diane, and we're the PC Zombies. And we've already done a video on how to avoid static shock, and it was just a bunch of rules that you need to follow in order to not have it happen. This is for the people who memorize things. But this video today is going to be for the people who want to understand the concepts so that they can make their own decisions on how they are going to deal with static shock. So we're going to cover 5 different concepts about static shock. The first one is, what is static shock? Static shock is what we call it, and we're going to call it in this video. But when you're out in the real world, it's called electrostatic discharge. That's the official term. And it's often abbreviated ESD. And I'm telling you this now because if you ever go out to Amazon to buy a wrist strap or an anti-static mat, you can either look it up as an ESD strap or an ESD mat. But if you're really at Amazon trying to find an ESD product, you probably ought to start with the ones we're going to use today, and we're going to have in links on this video. We all know basically what static shock is. That's shuffling around in your socks on the carpet and then touching a sibling and making them go, woo.
It's not how you feel, it's what happens.
All right, so here's a simple version of the science. When an object with excess negative charge, which means it has a lot of extra electrons, and you get electrons by walking through the carpet, rubbing your feet when you have your socks on. When that object touches a positively charged object, which is an object that has excess protons, the electrons from the negative object jump to the protons from the positively object, and the neat part about this is it causes a shock in the negatively charged object. Now, have you noticed how I've been waving my arm at her and she's the negatively charged object and I'm the positively charged object? That means when she is bad and touches me,
I get punished.
Gets the shock. So the real math of it all is, or the science is, that it's a karma thing, dude.
Okay.
When you touch a sensitive electronic component inside of your computer, you may not even feel the shock, but you are going to be giving up your electrons at a rate that has a voltage associated with it. That voltage will, if you're walking across a carpet, is up to like 12,000 volts, and it transfers in less than a millionth of a second, a microsecond.
Wow.
That fast. So and the feeling of the pop happens then. So here's the deal. If you have 1,000 volts, you'll see a light little spark at night if you have the lights turned off. If you feel a pinch and you hear a snap, you're probably around 8,000 volts. Okay. And like I said, you can work your way up to 12,000 volts. At that point, and you touch your big brother, you're going to get beat up.
Yeah, I can imagine. Isn't it true that modern computers are less prone to static shock?
Okay, well, that's a good question. No.
Oh, really?
No, in fact, they're more prone to static shock. So this is a myth. And they're more prone because they're putting more transistors in a chip. It just may be harder to tell what that damage is. For example, a CPU, you could damage the memory controller on the chip and may not know it because you only touched one part of the chip that got to that point. The computer chip looks like it's going to work, and yet it may drop memory bits here and there, and it's going to be ruined. In fact, I looked it up on the internet, and they said that 10 volts is enough to destroy a hard drive.
Oh, wow.
But 1,000 volts definitely can destroy most sensitive computer chips and things like that, circuit boards. So you don't want to touch those circuit boards anywhere where there's metal, because that discharge occurs, and you're going to have a big problem.
So how do I prevent static shock?
Okay, you need to neutralize it. And the way you neutralize it is when we're talking about the protons and the electrons trying to get together, have a party, right?
Right.
Once they get together, once we touch each other, at this point we have been neutralized against each other. But let's say you had a lot more negative charge and I only had a few protons. I took some of them to the point where you're neutralized and I'm neutralized, but I now have half of your electrons because they try to even themselves out. They're all balanced between the two of us. But we're still more negatively charged as each other than, say, that doorknob over there. And we go and we touch the doorknob, boom. How did that happen? Well, that happened because although I took some of your negative charge, I couldn't take it all, and now we both have excess negative charge, because she's really negative, guys.
I was like, I had a bad day.
Yeah, she had a bad day. She can't be blamed for it. So the best way to truly neutralize it is not to even yourself out with another object, such as when you touch your computer case, you're evening yourself out with the computer case.
Right.
But you're not necessarily evened out with that memory chip you're about to pick up. And so what you want to do then is you want to get to where you're truly neutralized with something that we know has so many protons and electrons that there's a vast abundance of it. And that is the Earth. And they call it ground. And so the best way to neutralize yourself is to touch ground. And the easiest way to do that is to go to an electrical outlet and touch the screw that's holding that plate to the outlet. That screw is grounded, and that grounds you. What happens is that you'll instantly be neutralized. And here's the best thing about ground. When you're neutralized by ground, neither you nor the Earth receives a shock.
Okay.
It has an abundance of protons and electrons. And if you're a negatively charged object, it has unlimited protons to absorb your electrons smoothly and easily without causing a shock. And if you're a positively charged, I keep doing my if you're a positively charged object like me, then the Earth will immediately give me enough electrons to balance out my protons, thus neutralizing me and preventing me from causing a shock. So now I can pick up that memory stick and it will also become neutralized instantly without shock. So touching that grounded outlet causes you to be neutralized. But as soon as you let go of the grounded outlet, you start to become out of balance again. Little tiny things, especially if it's a dry air, or you're wearing synthetics, or you're walking across the carpet like this, that's going to cause you to recollect a charge. At that point, the best thing to do is not touch anything else after you let go. Well, you can't work like that, so they've come up with easy ways to get to where you are working like that. And the neatest thing about it is once you're grounded by one touch with one part of your body, your entire body is grounded. So, your other arm is good.
Okay, you want to neutralize yourself and you want to stay neutralized. How do you do that?
Okay, well, first of all, we know that you got your finger in the socket, you're safe. You're not safe. You're Homer Simpson.
Yeah, that's right.
Don't put your finger in the socket. We all know if you have your finger on the screw now, you're grounded, you're neutralized. But the outlet's out of the way. So first thing, there are extension cords that take ground closer to you, like this. And if you look at this closely, it's got a round plug on it that you could plug into the ground part of the outlet. Little hole in the bottom is ground, and now it's like an extension cord. It's got you all the way up here. The other end of this is metal that you can snap to if you have the right size snap, or you can clip to if you have a clip. So Di, put on your wrist strap. I'm gonna just clamp it on to this. Now Di, you are neutralized. She's neutralized, I'm not. I am now. I'm not. I am now. I'm not. I am now. So when you make somebody...
That's a little irritating.
Oh, you should see my brother at Christmas. He's way more irritating than me.
I agree with that.
Okay, so now you're neutralized. But you really want to work with your computer components neutralized as well. So what do? You get an anti-static mat. We got one right behind you, Di.
Okay.
We'll link to this in our description. This is a StarTech mat, good brand, good company. And it takes probably about 2 days with some books on it, and it stays flat for you. This mat has a button that you could snap it in. Now this part, we're gonna hook up to ground. We'll just use the extension cord. And now the mat is grounded. So now...
I'm not grounded yet.
She's not grounded and I'm not. Oh, I'm grounded, I'm not. I'm grounded, I'm not.
Okay.
Go ahead, make yourself grounded. Just clamp on anywhere on the mat. The whole mat's grounded, just like our whole bodies are grounded. So now you've got a grounded mat. Any components you put on there will be grounded. That means it's neutralized. So we're creating a force field and we're carrying that force field from the socket up to the mat and to other places. Now remember, Di, we said, don't do this during a lightning storm. Don't work on components. Well, we can't do anything about that, but there's a second risk of shock. You are now connected to the ground in the building we're in the studio. Well, what if someone on the other side of the building suddenly starts screwing a hole in the wall for hanging a picture and they cause a shock to the electrical system of the building? Well, that shock you can do something about, and that's why they have surge protectors. You could plug in a surge protector first into the wall and then plug your little ground guy into the surge protector. Now this is a little bit better. If there's a shock somewhere else in the building, you're not going to get that shock.
Okay.
The other way to do that is there are actual products you can buy. We're not putting a surge protector on our list, but we will point to these. This is a product that has plastic where the electrical connectors are and a metal where the ground part is, which is all we want. Mm-hmm. You plug this part into a normal socket, and now the other side of this can be hooked up And this can actually act as your extension cord if you don't mind it being, springy. And now you could clamp on or snap on to the snap at the top of this. So that's one way. And there's also, and these are really cool, these are just mini surge protector, one outlet. You could put one here, plug this into the wall. A blue light comes on when it's working, and plug your ground into, which is what I like to do. Now here's what's nice about these. Say you bought a really fancy TV, try putting this onto the wall outlet and then plug your TV into that, and now you've protected it. When the building gets a shock, it's not going to make its way to your fancy expensive TV.
I like those.
You like those, huh?
Yeah.
So now you understand everything about static electricity you ever wanted to know, and it was fun, and the concept now of how you know when you're grounded and when you're not. And if I still have to go across the room to grab a memory chip, I know I'm not grounded, so I'm going to be careful. I'm going to handle it properly, and I'm going to get it back safely to the mat, and then I know I'm in better shape to now actually insert it or work with it.
And I'll avoid them on his way.
Hey, you're the one with the negative charge. Okay, guys, thanks for watching. Really appreciate it. Stick around. If you're building a computer, subscribe.
And please give us a thumbs up if you like the video.
All right, thanks. Bye, guys.
Bye.
Now you're going to shoot me a couple of times. No, not like that. Let's try.